Hi and welcome to my maths class. Today we're going to discuss the theorem that states if two tangents are drawn from the same point, then they are equal in length. Now look at what they say. A tangent means that the line touches the circle only at one point. So there's two tangents, 1 and 2. But they are coming from the same point. So both of them are coming from C. If they are coming from the same point, then they are equal in length. Now when they say equal in length, let's say I extend this tangent. Then this line looks fairly longer than the other line. But what they mean when they say equal in length, they are specifically referring to the length from the point to the circle. So they're not referring to the entire length of the tangent. They're referring to the length from the point to the point of the circle. From the point to the point of the circle. So in other words, they are referring to the distance of AC and CB. So if two tangents, you now understand what a tangent is, are drawn from the same point, then they are equal in length. What we write as a short form, tangent from same point. Okay. A lot of times you'll see that the short form is exactly what you're seeing. It's a tangent from the same point. Now, this is one of the theorems that is required for department proof. So you have to do it correct. Let us start with what we are given. We are given the center O, and then we've got two tangents. We've got tangent CA and tangent CB. Now, what is it that we want to prove? We want to prove that line CA is equal to line CB, because we want to say that they are equal in length. What are we going to construct? We are going to construct a chord from CO. So basically from the point to the center. Then we also going to construct OA. So again, it's from the center to the tangent. That is important. And we've got OB, center to the tangent. Now let's look at what we have. Once you've constructed these lines CO, OA and OB, we know that if we have B1 and B2, A1 and A2. Now let us look at the triangles AOC and triangle BOC. Now in the two triangles, what you would notice is that first of all, CO is common in both triangles. So we have CO is equal to CO. It's common. Then a line drawn from the center to the circumference gives us a radius. OA is a radius and OB is a radius. So we've got OA is equal to OB. They are both radius. Radii for plural. Then the important part. When you've got a radius and a tangent, once they meet, what happens to the angle where they meet? It becomes 90 degrees. Likewise, a radius and a tangent, 90 degrees. So we have that A1 is equal to B1. And why? Because they are both equal to 90 degrees. But the reason is tangent perpendicular to radius. The tangent is perpendicular to the radius. That is now the previous theorem that we have learnt. Once we have that, we have now that this triangle AOC is congruent to triangle BOC because of our 90 degrees hypotenuse side. And because they are congruent, we can make a deduction from that. The deduction is that AC would equal to BC. Now look at what we did. AC, which is the same as CA, is equal to BC, which is the same as CB. You've now proven the theorem. Thank you for watching.